Good afternoon, everybody. I want to thank everyone for joining me in this session today. This is being recorded, and you'll receive a link to be able to review it again later or share it with any of your associates. My name is John Witchy, and I'm the sales manager for Spindle. For those of you not completely familiar with us, Spindle provides operations management solutions, doing everything from automatically tracking productivity for operators and equipment, monitoring of downtime events and engineer activities, scheduling maintenance and supplying an interface to manage work orders, and tracking utility consumption with calculations of usage per pound or kilogram of production. Today, we're going to discuss predictive technology and how it is used in industry and our lives in general. We'll review a few examples of its impact and how it could affect and is already affecting the laundry business. Now, being descriptive basically comes from collecting information that explains what has happened. Even for systems that collect and present data in real time, the information is still only descriptive, telling the story of what has occurred up to this point. For example, I can be made aware that I've processed 2,000 sheets thus far today from a manual log or a counter or a control system software. Now, being prescriptive mines this data and uses analytic tools to identify causes and outcomes, perhaps combining multiple sets of information to generate recommended actions. For example, if I find that I've produced enough pillowcases to meet today's demand, but I'm low on sheets, I should now switch the focus for my, say, multifunction ironer from small to large pieces and catch up on my sheet classification. Being predictive puts the collected data into a model so that it can help me plan ahead. For example, I'll need X number of sheets tomorrow, and I know that the capacity and performance of machine Y should meet that requirement. Oh, and production employee Z is historically my most efficient feeder to staff on that machine. Thus, this is how I should schedule tomorrow for optimum performance. Now, here's a more detailed definition of predictive technology. It's the use of tools to monitor and analyze patterns in order to forecast likely future behavior or outcomes. The analysis is performed by software that is designed for data mining, modeling, and simulations, and the inputs can come from a multitude of sources, sensors and other signals on the equipment, or web activity, or even responses to customer and employee surveys. Now, in simplest terms, data plus analytics leads to insights. The concept is straightforward, and we do it every day in our heads. But the analytic tools to replace our brain power, the artificial intelligence, are pretty complex. Think of how much faster any function is performed by software when you're doing mathematic calculations or searching through quantities of data, and then consider that speed applied to the variety of situations we have to judge every day. How much might that improve your decision making? Now, to date, predictive technology has already been applied to weather, traffic, stock market, and consumer behavior, among other applications. So what can we expect? Ganesh Bell is the president of an industrial data science and artificial intelligence developer called Uptake. He has said that the technology already exists to collect information and reimagine the world's oldest industries. He forgot to include laundry on his list, but I added it for him. And he estimated that just 1% of data was being used in the industrial world as of when he made this quote in 2018. Now, 3 years later, we may be well beyond that 1% mark, but there's still so much opportunity out there. To present some examples from our everyday lives, I wonder how many of you out there might use Amazon or Spotify, and finally Netflix. Now, each of these companies has used predictive technology to affect us in our daily lives. Based on purchasing history, Amazon has actually created a patented anticipatory shipping model, which predicts what users will buy, when they will buy it, and where they will need it. Thus, they are able to stock items in their warehouses appropriately. In entertainment, both Spotify and Netflix use data to personalize their offerings for their customers. Spotify creates a customized playlist each week for its users, If you've never checked it out, you can click on the Discover Weekly playlist from your homepage. And Netflix chooses shows and movies to recommend based on your viewing history and the preferences that you indicate. Now, speaking of entertainment, what can Kevin Spacey teach us about predictive technology? And this lesson has nothing to do with the roller coaster of news stories surrounding him in the last few years. It has to do with one of our last examples, Netflix and the show House of Cards. Joris Evers, who is the former director of global corporate communication for Netflix, once said, there are 30 million different versions of Netflix. And what he meant by this is that their system tailors the Netflix experience for each of their customers. As I'm sure you realize, Netflix is constantly tracking your activity in order to create that customization. Rather than just make a recommendation of an action movie to a fan of the genre, they check your ratings of things that you've already watched. And Netflix takes viewer history and all of those ratings one step further, and in this case, determined where a large sampling of their customers' preferences might align and present an opportunity. Based on views and ratings, they identified an extremely popular director in David Fincher. They identified a very popular TV show in the UK version of House of Cards, which was a miniseries that originally aired in the UK in the 90s. And then a well-known actor in Kevin Spacey. So a Venn diagram showing the overlap in relatively large numbers in this case for these three pieces of information led them to spend $100 million on development of their own original series. They bought the rights to the show and spent this money on production of their own version, directed by Fincher and featuring Kevin Spacey. Then they even used that data excuse me, to focus their advertising. So customers who were fans of Kevin Spacey saw ads for the new show that highlighted his character and his past roles. The ones who liked David Fincher saw those brought to you by your favorite director commercials, and watchers of the original House of Cards received news about its reboot. Now, did it work? Let's see how they did. These numbers show Netflix streaming subscribers for 2013 and 2014. And 2013 is when their version of House of Cards started. The total number grew by 12 million subscribers from Q1 2013 to Q1 2014. So they didn't just satisfy the wants of their existing base and maintain their subscriptions, they brought in more. The minimum membership fee for Netflix in 2013 was $7.99 per month. So at a minimum, this means that they realized a monthly increase of roughly $96 million. Now, certainly, House of Cards isn't the only program that can take credit for the increase of Netflix subscribers, but they definitely covered their investment in it with their growth. Netflix has continued to spend money on other original programming and on obtaining exclusive content to build their numbers, as is shown in these two charts right here. I heard at one point that they paid another $100 million to get the show Friends for 1 year, just 1 year. And all of these decisions have no doubt been based on their predictive technology. Hate to build regrets among those of us who didn't buy Netflix stock 10 years ago, but look at where they were in 2018 after making those kinds of decisions, in no small part due to their predictive technology. Now, to provide another example of predictive technology, and to move about as far afield as from Netflix as I can imagine, let's review the benefit and the return on investment made by a global mining firm that implemented predictive technology. Now, this business needed to minimize the unscheduled downtime incidents for the 10,000 rail cars that they utilize to transport high-value iron ore from mining sites to the seaport. They calculated that each unscheduled downtime event cost them an average of $6,000. They were already using devices to record such things as wheel impact load, hot box temperature, and bearing acoustics, so they were already being descriptive, collecting that information to be able to review history. But their next step was to employ a model, and they used a company called Uptake, which, if you remember from a few slides back, that was run by Ganesh Bell, who made the comments about the future of predictive technology. And Uptake, built a software model that analyzed the data and predicted high severity alerts, medium severity alerts, and opportunistic events to perform maintenance on the equipment. By doing so, they reduced unscheduled maintenance downtime by 50%, going from approximately 1,850 per year to roughly 925 per year. So this improvement represents an almost $30 million savings over 5 years. Now you may be thinking, that's nice for Netflix with metrics collected from millions of customers every day, I don't have 10,000 pieces of equipment like those rail cars. However, let's look at just a sampling of the data points that exist in a laundry. This page represents metrics that could be obtained directly from equipment and processes, and I haven't even included every laundry process in this starter list. I got tired of listing things. There's so many. There's plenty of data out there. And among Spindle customers, we collect 40 million counts related to production every day. And the market is far from saturated. So whether we're talking about our solution or other people's manufacturer solutions or systems, there's a large amount of data still not being collected automatically for similar data points all across the industry. Now, there's also significant information that could be recorded about your customers and your markets or even your personnel that you could put into these predictive models. Now, of course, pulling metrics from equipment requires an investment in sensors, meters, and other data collection devices, whether they're installed during manufacturing or they're retrofitted onto the equipment. Most importantly, there is a need for control system firmware and computer software, since that's what's going to do the heavy lifting with modeling and with calculations. So this brings us to Industry 4.0 and the Internet of Things. Now, Industry 4.0 is the latest step in the industrial revolution. The examples we reviewed thus far have been a result of this evolution. And again, the opportunities are everywhere, from entertainment to mining to laundry and everything in between. In this diagram, we look back on the progress from the initial mechanization of industry, which obviously sped up manufacturing activities, to mass production, which improved repeatability of process and improved quality standards, to automation, robotics, and computer controls that reduce the manual labor and production employee level decision making. And now finally, with Industry 4.0, the ability to network formally separate systems, access data remotely, and use the software tools to analyze all this information and help us make informed decisions, or even enable the software to make those decisions for us. Now, I mentioned earlier that there's a payback from investments in predictive technology, and the returns come from bringing multiple systems together, which saves time in reviewing and analyzing data, having access wherever and whenever we need it, improving uptime on equipment, thus increasing our asset utilization, and putting data in the hands of multiple people with analysis tools that don't necessarily require specialized expertise to recognize when a situation for improvement exists. Now, one of the modeling tools that is used in Industry 4.0 is what's called the digital twin. Now, whether it is as detailed as a 3D model or it's simply a list of inputs, digital twin creates a set of parameters that can be monitored and evaluated. There are 3 components. In our industry, we can design for an entire laundry or even just a single piece of equipment. Then there's the digital version, which is the model created within the firmware or the software. And finally, there's the transfer of data between the two, which requires, as I mentioned above, input mechanisms for preferably collecting data automatically. Now, there's a number of methods or analyses tools that we can use to generate the predictions for any situation. Now, 5 popular labels are listed here, which could each certainly be seminars of their own, I'm sure, but a couple can be used to describe the examples we reviewed earlier. I can't say for sure, but I would assume that Netflix used some form of the clustering model in order to group the customer characteristics for making their $100 million bet. And then the mining business may have employed the anomaly model for identifying those conditions for when they should service their equipment. Now, pulling from the diagram shown earlier, there are plenty of buckets of data from which we can easily collect information in the laundry. The more challenging step, obviously, is to do so automatically. As I mentioned earlier, there's costs and sometimes perhaps other hurdles associated with installing the components and with implementing the analytic firmware and software. So, along with many U.S. industries, we are in the early stages of adoption, according to Stephen Ezell, who represents an industry think tank on science and technology policy. If anyone has any examples of perhaps receiving a rebate or completing a project that's saved on some sort of utility like gas, water, or electric, please enter it into the chat. And the reason I ask that question is that one of the things that Stephen Ezell recommends is funding for these type of projects. I can recall hearing of some businesses that received a discount or a rebate on electricity after installing variable speed drives to make more efficient use of power. I also believe there have been benefits for businesses after installing LED lighting and other electricity savings components. So again, if anyone has any examples they'd like to share, please feel free. But regardless, looking at Industry 4.0 and the opportunities for predictive technology, I'd recommend let's not hold our breaths for those subsidies and those kind of programs, but rather focus on the technology and the ROI that's currently available and the operator and vendor cooperation to create additional solutions. Spindle development, and I imagine much of the industry, is often fueled by those ideas that come through communication with our Spindle-ready vendors, our customers, and our prospects. Now, this diagram represents the maturity model of predictive technology. At a minimum, I would guess that many of you are in at least the early stages. Passive reporting includes those Excel spreadsheets that I know many of you have on your computers with tons of fields for data entry. And I know that you have them because I borrowed these examples directly from some of our customers. So you're calculating your key performance indicators or KPIs and presenting them in charts and dashboards takes us to the next step where we can begin to be proactive. In the laundry industry, our technology has advanced us into the next stages where we create more useful visualization, we start performing more detailed analyses, and we combine data from various sources in order to become at least prescriptive. The following images come from Spindle, and we, along with many of your other equipment vendors, are all working on the next level development that's dedicated to improving your anticipation of how to run your business, using staffing analyses to see where our team members should go, maintenance scheduling, assignment, and tracking tools, online access to data from interrelated sources, production requirements and real-time updates on your progress, monitoring equipment sensors to indicate parameters that are out of tolerance. Remember our rail car mining example from earlier. And then finally, mining data from various aspects of the business and distilling it down to on-the-fly recommendations. In other words, becoming truly prescriptive. Now, as far as we've come, imagine where we'll go from here. As we develop the artificial intelligence to become predictive, we'll truly hit a transformational point in our industry. Modeling like a digital twin will help us better determine future activities and make decisions. Machine learning is becoming an incredible tool when we incorporate it into our businesses. With machine learning, the models that are created will actually, quote unquote, grow and develop on their own. The software will make its own adjustments to the model based on actual experiences of cause and effect. So how interesting and exciting is that? It's basically like a computer learning like a child, accidentally touches a hot stove and then rewrites its own code to include do not touch stove while cooking, it's hot. Ongoing developments with vision systems will be amazing as well. While these aren't in and of themselves predictive technology, they have the power to provide very unique input for our predictive models. They're already used in some inspection applications, but we obviously have challenges when handling textiles, which don't exist elsewhere, because our goods need to be presented flat and smooth, or a basic vision system can't identify how it really looks. You know, the wrinkles that we see on this page might sometimes be interpreted as damage or stains or tears. However, as technology advances, as our machine learning continues to improve the response to the inputs coming from the various systems, these drawbacks will be overcome, and vision systems could be a major enhancement for our industry. So we've come a long way, but I hope you're excited about what's next. When it comes to automation, consider the advantages of more developed real-time decision-making for the robots and systems currently in use, and think of those that we'll have at our disposal in the future. Now, to end on a light note, we've discussed machine learning and artificial intelligence, but just so no one's concerned about the rise of the machines, I wanted to point out that they do still need our input and assistance. If anyone has an Android or a Google phone, there's a function called Google Lens, where it will analyze an image to identify it. It works very well with things like landmarks, logos, artwork. And when my family and I are hiking, we use it to identify plants and flowers and trees and anything that we might see on the trail. And it does a really good job. I mean, like, look what it does with this image of the Empire State Building. It identifies it. It'll pull up websites associated with it. It'll pull up other images, etc. However, if you have Google Lens, check it out to see if it can tell the difference between a Chihuahua or a blueberry muffin, and you will find that it is not quite perfect. I've tested this on my phone with our Chihuahua Paco and some of my wife and daughter's homemade bakes, and it does not score 100% in differentiating between the two. In any case, best of luck as we together climb the steps of the maturity model of predictive technology. Collaboration between customers and vendors will make our journey pretty interesting, and who knows where we can go from here. Want to thank everybody for your time today. Again, this was recorded if you'd like to go back and take a look at it. But at this point, I wonder if anyone has any questions. Feel free to put them in the chat, and I will do my best to answer it, or hopefully the thought process going among our entire team that's on the call here today. I see Nick is plugging something in. I'm not sure if he has a question or a comment for all of you in the audience. Oh, and actually, yeah, mics are now enabled if you guys would like to turn your mic on and ask a question. Well, I hope the silence is a sign that I answered everybody's question, or I got you thinking so much on the topic that you can't speak. I hope I didn't put everyone to sleep. But thanks again for your time joining us. Certainly look forward to the future, and look forward to working with all those of you who are customers and prospects out there to keep building on the enhancements that we've made to this point. I appreciate the time today. Thanks.